Hello, Clore Scholarship Committee. My name is Yonatan Nir, and I'm excited to introduce my PhD research, Looking Without Seeing. Visual search is a ubiquitous part of life, whether we're looking for our glasses on a messy desk or searching for a vacant parking spot for our car. But, as anyone who's ever played Where's Waldo or FOFE knows, we sometimes miss targets even though they are clearly visible to us. These looked but failed to see errors could have devastating outcomes when they appear in high-stakes contexts like radiology and airport security screenings. Additionally, from a neuroscientific perspective, these errors provide a unique window into the links between important cognitive mechanisms like perception, attention, and consciousness. One specific question that has been long debated among cognitive neuroscientists is the existence and nature of unconscious perceptual processing. So far, most of the research on this question used non-naturalistic experimental designs. Stimuli were presented exactly at the threshold of conscious perception, and eye movements were suppressed by having subjects fixate at a single point on the screen rather than move their eyes freely. Looked but failed to see errors provide a unique and ecologically valid way to examine unconscious processing in naturalistic settings. My PhD pursues two significant goals. One, to identify the behavioral and neural signatures of looked but failed to see errors. And two, to use these errors as a method for examining unconscious processing in a naturalistic setting. To accomplish these goals, I will focus on three aims. First, in a soon-to-be published article, I developed a method for benchmarking eye movement processing algorithms and identified the top-performing algorithm for analyzing free viewing data. Currently, I'm working to identify the behavioral signatures of looked but failed to see errors using our novel visual search paradigm. And finally, I will investigate the neural correlates of looked but failed to see errors to examine the extent of unconscious processing in free viewing conditions. This research could provide significant strides in real-world applications, such as driving assistive technology, radiology, and many more. Additionally, it could advance the field of cognitive neuroscience by providing ecologically valid answers to the long-debated question of unconscious perceptual processing. Thank you for considering me for your scholarship.